Hello, Honors Algebra 2 people. Here is a review for our logarithm unit test. It is Unit 1, Topic 3, Part 2. Part 1 was exponentials, Part 2 was logs. It is a no calculator test, so you should not use a calculator for anything on the review. Evaluate means we want the exact number. If I wanted an estimate, I would say estimate. So for number 1, 3 to what power is 1/27th? And I'm going to make the bases the same. So that's 1 over 3. But then with a property of exponents, 3 to the third. With a property of exponents, I can make that exponent negative and move it to the numerator. So the what power is -3. That is my answer. For number 2, 2 to what power is 64? Well, 64 is 2 to the 6th. For 3, it's a lot easier if you think of 0.1 as 1/10. Then it's similar to number 1. So the what power is -1. And then for 4, 4 to what power is 32? 4 and 32, well, 32 cannot be made into a base of 4. So I'm going to make both into a base of 2. So 2 squared is the 4. 2 to the 5th is 32. So 2 times what power is 5? 5 over 2 is our answer. So for number 5, all of these evaluate. So my explanation is I evaluated all expressions. And number 6, we're going to have to do some estimating. So I'll have a longer explanation. So 4 to what power is 4? 5 to what power is 1? 2 to what power is 1/4? That's similar to what we did up in 1 and 3, so that's -2. 3 to what power is 1/3? And 6 to what power is 36? So if I'm going to put these in order, the smallest is C, and then D, and then B, and then A, and then E. Okay, 6, we got some more work. A, B, and D are not exact values. C is saying E, because that's the base of an ln, to what power is E? And for part E, E to what power is 1? Now for the rest, for like A, 2 to what power is 9? Well, 2 to the 3rd is 8, and 2 to the 4th is 16, and 9 is in between 8 and 16, so W is between 3 and 4, but closer to 3. So we'll say approximately 3. For B, 3 to what power is 10? Well, 3 squared is 9, and 3 to the 3rd is 27. So the what power is between 3 and 2, but closer to 2. Let's say approximately 2. And for D, 4 to what power is 5? 4 to the 1st is 4. 4 squared is 16. So 5 is in between there, so the what power is between 2 and 1, but closer to 1. So I'd say a little greater than 1. So 0, 1, 2, 3, 4. So the smallest would be E, then comes C, then comes D, then comes B, then comes A. All right, transformations in 7. The 2 multiplied on the exponent is a horizontal dilation of a half and up 3. Now for 8, we have to isolate the exponential. Your test is no calculator, so you can't get 2 decimal places. We're going to leave our answers exact. So we're going to divide by 3. 3 does go into 384. Sorry the camera keeps shaking. I'm on a wobbly table. that's 128. Then I'm going to change it to a log and add 5 to the left. For number 9, I'm going to first subtract 100 because I want these constants on one side. And I'm going to subtract the 10 to the 2x to the left. And this is a little tricky looking, so let me ask you a separate question. If I had 4 times y equals y plus 900, so here's my 4 times y equals y plus, and then the 900, and you subtracted y to the left, you'd be left with 3 y's. So, in the same idea, 4 10 to the 2x's minus 1 of them leaves me with 3 10 to the 2x's. Divide by 3. Change it to a log. And when you divide both sides by 2, you may not simplify this argument. The log is protecting it is the way you can think about that. So it's log of 300 all divided by 2. Be careful, the y scale here is in tens. I don't want you to, if you're counting rise over run, to miss that. So from 8 to 12, so here's 8, 12, 80. So the average rate of change is slope. That is 40 over 4, which is 10. You must include units. It is megawatts per hour. So the instant rate of change at 8, you need a straight edge. So you can use a separate piece of paper. You can actually use a ruler, side of a tissue box, whatever you want. So at 8, here's where x is 8. It's at this point. I'm going to line up my straight edge so that I'm tangent. Now this is intersecting, and we want it just to skim the graph there at 8. Draw the tangent line. And I'm going to look for another nice corner point that it goes through. I'm going to go with here. So depending on how you draw your tangent line, we might have different answers. So that's the point 840 and 1370. So the slope is 70 minus 40, 13 minus 8 is one way you can do this. Or you could count 1, 2, 3 for the rise, which is 30. 1, 2, 3, 4, 5 for the run, which is 6 megawatts per hour. Oops, sorry, you can see that. The 13 minus 8 is 5, or you can count it, the run, 1, 2, 3, 4, 5, and 30 over 5 is 6. If yours doesn't reduce, leave it as a fraction. 29 over 5, well, that wouldn't happen because it's by tens. Whatever, if it's a fraction that doesn't reduce, it's fine. Leave it as a improper fraction. All right, number 12 is Newton's law of cooling. So we've got 65 degrees as the initial temperature, and it is put into the freezer, which is the ambient temperature, and here's RK. So the function T is the ambient temperature plus initial temperature minus ambient temperature, e to the negative 0.04 T. And even without a calculator, 65 minus 2 leaves a coefficient of 63. All right, 13 for graphing. To get my asymptote, I'm going to set the argument equal to 0 and solve. We get x is negative 4. don't forget to draw a dashed line. Now for two clearly plotted points, I'm going to set my argument equal to powers of the base. So that's 2x plus 8 equals 2 to the 0, 2x plus 8 equals 2 to the first, and let's do one more, 2x plus 8 equals 2 squared. If I solve all of those, I get the y values for my table. So let me just work backwards since I didn't leave myself much room. So that's going to be -2. This one, let's see, that's 2x equals -6, that's -3. And then this last one's going to be a fraction. Don't panic, it's going to be -7/2. So if you don't want to graph -7/2, we're only asking for two clearly plotted points. You could leave that one out. We're going to evaluate it to get the y coordinate. So let's do the -2. That's -2 log base 2 of -4 plus 8. I did 2 times -2 in my head instead of writing it. So first we have to evaluate the log. So 2 to what power is 4 times -2 gives us a y value of -4. Let's do the same thing with the -3. So 2 to what power is 2 times -2 is -2. So -3, -2, -2, -4. So because we're going away from the asymptote, my graph is decreasing. The range is all reals and the domain is x is greater than -4. All right, for 14, 3 to what power is 27 to the x? Because there's an x here, you should not use an x for your what power. W, an initial, anything but x. So now I'm going to make 27 into a base of 3. So the what power is 3x. So this equals 3x. The inverse function of a log is an exponential, so don't forget inverse notation is y to the -1. And changing that to an exponential would give me 4 to the x. To solve 16, I'm going to change this to an exponential form, so 3 squared equals 2x plus 1. So that's 9 on the left. Subtract 1, we get 8. Divide by 2, and our answer is 4. And the back. Transformations, asymptote, domain, and range. Left, 2, and down, 5. Oh, almost can't see that, sorry. When the argument is 0 is my asymptote. Range of a log is all reals, and there's been no reflection over the y-axis transformation, so my domain is x is greater than -2. If you think of the parent function, it's to the right of the asymptote. If we reflect it over the y-axis, it goes to the left of the asymptote. But we don't have that reflection, so it's greater than -2. This one is to the right 2 and up 3. X equals 2 is the asymptote, and x is greater than 2 is my domain. This negative is a reflection over the x-axis. The argument is just x. If there's no parentheses and that freaks you out, you can put them in. But if we wanted the 2 grouped with that, we would have to give you parentheses. No parentheses implies that just the x is the argument. So then this is also down 2. So the asymptote is at x equals 0. And again, no y-axis reflection. So x is greater than 0. This 4 coefficient is a vertical dilation of 4 and down 1. X equals 0 is the asymptote, and the domain is x is greater than 0. So you should print another blank review packet from our Drive folder and see if you can do every single problem confidently with no help before the test this year. It's on Monday. Do not have the first time you do these problems independently be the test. You should do them independently as you study. That way you know you are prepared for the test. Give yourself a little break now. You've just watched every problem, or hopefully watched the ones you needed help with. I don't want you memorizing what I've done. You need to be able to do it by yourself. So go have a snack, go exercise a little, take a walk, do something, and then come back and try your math again. Bye.